So it cannot give you the desired condition. It is of no use, whether it may be of higher energy efficiency. Two, look at the total cost efficiency of the equipment and then the total cost of ownership. These are the three parameters one should look at while deciding on what kind of refrigerant or what kind of equipment to buy for. Thanks.
Thank you, Sanjay. I'd like to share few points on because it's more on the perceptions on using which refrigerant because people, those who have used some refrigerant feels why should we change it to another alternate refrigerant. The people who have been using a CFC refrigerant or 22 or 404A, that series, then when they are setting up a new project, it's reluctant for them whether ammonia will work, whether ammonia will be safer, or can I get an operator, basically, to handle a centralized ammonia refrigeration system. As he rightly said, it is more on, the product, it's more on the application, the size, the number of rooms, the ambient conditions, the availability of water, and what kind of condensing method which you would like to have. So there are various evaluation criteria that is required to be done before we really judge which refrigerant will fit to a kind of an application. Now, of late, you have been you have been coming across for a period of time about the safety of the cold storages, especially ammonia has been quite extensively used in our country in cold storages, especially in the northern part of the country. And because of various reasons, either it could be not because of ammonia leakage, there is a lot of accidents that are happening. Now we have a separate session for that one, which is going to be addressed a little later. But to address the audience, Frickinde has been a company working in using ammonia as a refrigerant for I would say about more than 50-60 years. Would like to like to tell audience to share his experience on how safe for ammonia as a refrigerant, vis-a-vis other refrigerant is concerned. Yeah. Yes, Mr.
I think most of the points has been covered by the other panelists. But I would like to add that there is a misnomer, like ammonia is dangerous. Even in the earlier presentation, it was written dangerous. See, dangerous, you find accidents happening. A BMW car having burning in front of Worli Sea Face. Okay, or a LPG cylinder blasting in your home. So we are all living with these kind of dangers in our day-to-day life. So it is basically, these are accidents, or I would call it as incidents. And it is happening mainly because of negligence and ignorance. See, one is, ignorance is, there are certain standards to be followed while you design a plant. Like this much thickness plate should be there, and you have to have a radiography welding. Those kind of standards which needs to be followed up. So this is one thing. And the other one is, ignorance is you don't have a trained, skilled operator who goes and closes a discharge valve. And then if there is some incident taking place. So that you cannot blame the ammonia as a whole. See, in India, if you take the food processing sector, I would classify at least 90% of all our food products which are being stored in India are running on ammonia refrigerant. And how many incidents or accidents, maybe off late you found 1 or 2 cold storages giving way and taking lives of about 7 or 8. But the actual thing what happened was, once the cold storage collapsed, then the pipelines broke and ammonia started leaking. It is not because ammonia cannot blow up a total building, So it is all like how it gets reported in the market. So rest be assured, if you take the safety precautions, like we have in this field for the last 60 years, and if you design the plant properly, and now there are a lot of innovative things which have come, weld-in type valves have come, ammonia leak detections have come. So there are a lot of, even the Newton CO2 system, which they showed you in the presentation, there is a separate unit for even in case of a mild leakage happening in ammonia, which is completely scrubbed off and taken out from the plant. So there are a lot of precautions which can be carried out, and it is, I would say that on point of safety, I think ammonia is like you can be 100% sure, like a lot of people here are using ammonia. Only thing is certain precautions and some safety features have to be inbuilt into your plant. So those kind of safeties you maintain, then you will not have a problem. But as Sanjay said that, I would rightly say if you want to put a cold storage here, where 100 people are sitting and eating and it's a small restaurant, so then I would suggest that it's a small cold storage, it can go with a small freon unit or something. The moment it scales down as an industrial refrigeration, then you have to see one is environmentally safe, the other one is the energy cost. So in both these fronts, like global warming potential is below 1 and also the ozone depleting potential is below 1. So ammonia is safe on those aspects. It's not going to heat up your Earth's temperature, or it's not depleting your ozone layer. So it's on a overall, it will avoid a major disaster. Maybe instead of one cold storage incident, it is going to avoid a over major disaster which is completely destroying our mankind. So that kind, if you see, then the alternate refrigerants which are coming are also, we need to be careful because they have a global warming potential and those kinds of things are happening. So natural refrigerants are the day, like ammonia, CO2, water. These are the refrigerants which we have to look into and go into the future. Thank you.
There were good discussion. Morning there was a presentation about commercial refrigeration by Mr. Vinay from Carrier Refrigeration India. He was just talking about the commercial products, commercial refrigeration product, which has been quite extensively been used in supermarkets, few small cold rooms and all. But in a food industry, in a refrigerator warehouse industry, cold storage industry, which uses quite big size capacities, it could be ranging from 1,000 pallets to 10,000 pallets and so on and so forth. Now, you have a choice. You have a choice to use the freon, you have a choice to use ammonia, you have a choice to use ammonia. But before getting into that point, we should clearly try to understand what is a commercial refrigeration and what is an industrial refrigeration. In terms of capacities, in terms of operating conditions, in terms of application wise. Before we take a decision on which refrigerant probably we could use it, right? Because that's the first factor, first parameter we would like to get into that one. Mr. Sanjay, you have been working quite a lot with the freon refrigeration plans for in your projects, and of course, Frick India has been working with ammonia for a lot of projects. How do you decide an area where you could tell your customers this is a commercial refrigeration application, 1,000 tons, 2,000 tons, etc. So let's go with the freon as a refrigerant. Then if it is a bigger capacity, let's go for a centralized refrigeration. This is an industrial refrigeration system. What kind of evaluation or what kind of points that you'd like to share to the audience on distinguishing between a commercial and industrial refrigeration? Yes.
I think just add to the whole thing, as you mentioned that I worked with Freon. I worked with Freon refrigerants for almost 13 years. And subsequent to that, for last, I'd not say 13 years, or almost around 17 years, I worked with Freon. And then for last 9 years, I've been working with ammonia and Freon both. So during the initial career, I almost spent with a company where it was only Freon. So when I started my own company, Infracool, I said, okay, I'll start doing the same thing what I was doing there. That I need to change the gears, learn ammonia, and try to give the right kind of solutions to the customer. Because most of the time, a company which has been dealing with the freon tries to give a freon-based solution, whether right or wrong. Similarly, a company dealing with ammonia, pardon my saying that, because they have been dealing with ammonia, they go with the solution of ammonia because that's something which they have been tuned to sell to the customer. That's what they feel comfortable with. So we as an organization said no, that we will go to the customer saying, we understand ammonia, we understand freon, we will try to give you the best solution what is possible. Whatever is the best thing to be available to do across. Okay. And coming to your question that how do we suggest, how do we look at? Now I've been predominantly operating in one sector of Apple for last 12 years. Whenever I go in for a large project which is 5,000 metric ton or so, my first choice of ammonia is not just because of the energy efficiency or the ammonia as a refrigerant. I find the application orientation of ammonia is far superior. I'm able to keep the shelf life of the produce to as long as 10 months, 11 months by using ammonia. Because I'm able to get better controls on ammonia, which I'm not able to do with Freon DX system. So considering that, I'm using ammonia for those kind of projects. But as soon as an Apple project, cold storage project with 1,000 metric ton only, I find ammonia would be an expensive proposition for the client. Okay, so in that case, I go in for a freon-based system. So anything about below 1,000 metric ton for an Apple storage, I decide to go in for a freon-based system. 2,000 metric ton, 3,000 metric ton, 4,000 metric ton system.
Okay.
I prefer to go in for a system which is more, because the controls cost is high. That's another impact to it, because the capital cost increases very high.
Okay. Mr. Sudhir Kumar, could you please share your views on how do you distinguish between a commercial refrigeration industry in
like
terms of
he has already
capacity?
told on the capacity wise. I personally feel that anything below 25 TR of refrigeration capacity, or if you are familiar with kilowatt, maybe about 100 kilowatt or less than 100 kilowatt is what you can look at, because the ammonia
100 kilowatt of power consumption or 100 kilowatt of refrigeration capacity? Refrigeration
rather
capacity.
even little lesser, around 70 kilowatt, I would say.
Roughly around 25 TR refrigeration capacity.
Because the range of compressors for ammonia starts from, say, around 50 kilowatt or so. So you will not be having, and plus, if the same 20 TR is to be divided into 3 or 4 chambers of 4 TR each, then you will have a little bit of difficulty in designing an ammonia plant. And then the second one is the area of operation. Like if it is inside a densely populated area, so there are certain restrictions which you can't use an ammonia there. So those kind of applications and areas where you cannot use, so you can think of thing. But the moment you go above 70 kilowatt, I personally feel ammonia can.
Yeah, thank you. Sudhir.
And one more thing, I think one more thing wanted was automation of, like, it's not necessarily like the olden days you need to have a lot of operators to run around with closing of valves and all those things. Now automation has reached a level where even in ammonia plant, with a very minimum or maybe one operator for one shift who can take care of a complete industrial refrigeration project. It's all now SCADA based and it can work on that. So there is some interesting presentations coming up after this. So I think they will be dealing with this.
Yeah.
Thank you.
Yeah, thank you, Mr. Sudhir Kumar. We have, when we always have a problem or a lot of confusions that will arise between choice of the refrigerant. Now, I have one more question to the panelist. Now, we have either in cold storage, these days we design the projects with the multi-purpose, multi-commodity cold storages, whether it could operate in plus temperatures, plus 1 degree, plus 10 degrees centigrade for the process halls, the receiving area, and then you have a chill rooms 0 degrees centigrade and frozen rooms minus 20, minus 25 degrees centigrade. It could be having some capacities, whether it could be 1,000 pallets each, 2,000 pallets each, certain area. Now, it's an industry where we would like to see how we have a choice, because when we are talking about HCFC refrigerant, clearly we can't use R22 as a refrigerant. It is almost it's getting depleted completely, so we can't use it. Now we have a choice of going with some refrigerants like R404A or 507 or 134A. But they are all mixers, basically mixers. Now we have choice, like either we could use different HCFC refrigerants in one storage, or we could use only one refrigerant, like a case of ammonia, to be used as only a centralized system. So we have probably a case where we need to decide a choice of a right refrigerant, where different temperatures needs to be maintained in different areas with the different capacities. So, Mr. Sanjay, could you please just tell us how do you deal with these kind of cases and take it to the customers?
Again, it will be project driven. Suppose a client has a 5,000 metric ton cold storage and he says, I want a 500 metric ton freezer. So I might, in a choice like this, offer him an ammonia-based system for the cold storage, and for the freezer, I may offer him a freon-based system. But suppose he says, I have a 2,000 metric ton freezer, and or a 5,000 metric ton cold storage, 2,000 of it has to operate as multi-use. That is, it is convertible chamber. I can use it for freon, I can use it for minus, as well as I can use it for plus temperature. That case, I'll probably select a refrigeration system, which is ammonia-based system, but catering in a different way, designing it in a different way, so that he can achieve minus 25 also in the same room, as well as 0 degree C also, or 2 degree C in the same room.
Okay, you suggest a single refrigerant instead of going for a multiple refrigerant to maintain a multiple temperatures, right?
Depending upon the usage.
Yeah.
I'd like to add, like what he said was, like if it's a big cold storage, like 5,000 tons with 50-50 of different temperatures, then ammonia can be used. Like you want a 5,000 ton positive cold storage and maybe a 100 ton butter store. So then there he says, only for that 100 ton, it cannot be possible in ammonia, and he will give a small separate freon system.
Yeah.
Rest all will be with ammonia. But like overall in the industry, where nowadays people are going with 60-40 or 50-50, so there you can have ammonia, you will have a booster ice stage system, so you can have negative as well as positive, and it can work on both the temperatures.
Okay. Thank you very much. Before we wind up the session, could you please, any questions from the audience? Yeah, please.
Yeah, I would like to have a question to all three people. The question of mine is, when we need to select indirect system, because you all three talked about the direct system, whether it is a different refrigerant, but there are the questions from the, you can say, different customers. They are preferring indirect system, either from brine or water as a media. So I know there are the different scale in terms of capacity, but how to select indirect system in terms of the project-wide project?
Okay. See, Himanshu, what happens, sometime when you look at a lot of people don't suggest a direct ammonia system because they don't feel they're capable of doing a direct ammonia system. Their quality of welding, like Sudhir mentioned, it is the good engineering practice, and the quality of execution at the field level is very, very important to execute a good project and then use the right safety. There is no question of having any accidents to happen. Now coming to a scenario where to recommend indirect system, brine system also, it is, if you are putting up a cold storage which is nearby a locality where the residences are there, then it would be recommended that don't go in for a large amount of ammonia refrigerant into the system. They're going for a brine, so that ammonia charge is as low as possible, restricted to the plant room. So even if there is a leak, it is the amount of ammonia is less. To give you an example, recently most of my Apple projects have been on ammonia based, the last size one, a 2,500 metric ton project. We are executing in an area where we found that though it's an industrial area, but surrounding to the industrial area, there was quite a good amount of inhabitant which was there. So initially we kept on telling the customer we would prefer to give you ammonia system, but when we went to the site, had a site survey done out, we said no, we'll give you a brine system with ammonia or freon, whatever you like to go in for, so that you can get still a better efficiency, better product quality, because product quality is the first thing to begin with. Any system selection, my recommendation is look at the product, what you're storing, how you can achieve the right condition for the product, then only you can get the result. Because you may save money, you may save power, you may save anything else. If the product is not coming out good after storage, you end up losing the money. Okay? So
I would like to add one thing. You mentioned water also. See, water definitely, like if there is an air conditioning application inside a process hall or a grading hall or something where a lot of people are involved. So there definitely we will use an indirect system, chilled water system. The ammonia being in the plant room, through a PHE we take chilled water and chilled water is generated. Like a huge hall like this needs to be air conditioned where 500 people are working. So there we use chilled water system.
Thank you.
See, the secondary refrigerant, either water or any brine, of course, the calcium chloride is not being used these days. Glycol is also one of the refrigerant. This is basically been used in food industry, dairy industry. Then they are also being used quite extensively in the chemical industry, drug industry, and other processing industry.